Hi all, this is Vinay. Welcome to Avers Technologies. Let's discuss the types of design patterns. There are three main types of design patterns. First, creational design patterns. Creational patterns helps to create an object in a flexible and reusable way. Second, structural design patterns. Structural patterns always deal with how classes and objects are combined to form larger structures. And third, behavioral design patterns. Behavioral patterns focus on the interactions and responsibilities between objects. Each pattern type has specific patterns that address different design challenges. Understanding these pattern types and when to apply them is crucial for effective software design. Introduction to creational design patterns. Creational design patterns are more focused on object creation mechanisms. These patterns are providing solutions to instantiate objects in such a way that it increases the flexibility and reuse of existing code. The purpose of these patterns is to abstract the instantiation process, helping a system becomes independent of how its objects are created, composed, and represented. The major and benefits of creational patterns include increased flexibility, better control over the creation process, and reduced complexity in ANV-object initialization. These design patterns, adapter, composite, and proxy, are helpful in systems that prefer using objects together rather than inheriting from a base class. This method focuses on being flexible and adaptable rather than sticking to a fixed structure. By combining objects, systems can change and grow more easily. Creational design patterns are a group of patterns which focus on object creation. And the group of creational design patterns are 6. They are: first, singleton ensures a class has only one instance, providing global access. Second, factory defines an interface for creating objects, letting subclasses decide which to instantiate. Third, abstract factory provides an interface for creating families of related objects. Fourth, builder separates the construction of a complex object from its representation. Fifth, prototype creates new objects by copying a prototypical instance. And sixth, object pool recycles objects from a pool to improve performance. Now we will discuss details about structural design patterns. Structural design patterns focus on the relationships and interactions between objects, helping to create larger, more complex structures. These patterns enable flexibility by defining how components can be assembled and modified without affecting the overall system. The major key principles of structural patterns include object composition, inheritance, and encapsulation. They emphasize efficient use of resources and the ability to adapt to changing requirements. The major benefits of applying structural patterns: developers can simplify complex systems, enhance code readability, and improve the overall scalability and maintainability of their applications. Many structural patterns involve the use of wrapper classes, composition, and inheritance to create new functionality or interfaces, allowing for increased flexibility and reusability. Let's explore each list of structural design patterns. The adapter pattern connects incompatible interfaces, enabling classes to work together that couldn't otherwise. The bridge pattern decouples an abstraction from its implementation, allowing them to evolve independently. The composite pattern composes objects into tree-like hierarchies to represent part-whole relationships. The decorator pattern dynamically adds responsibilities and behaviors to individual objects without affecting others. The facade pattern provides a simplified, high-level interface to a complex subsystem, hiding its internal complexities. The flyweight pattern uses object sharing to support large numbers of fine-grained objects efficiently. The proxy pattern provides a surrogate or placeholder for another object to control access to it. The module pattern organizes code into separate, self-contained units for better maintainability and reuse. Behavioral design patterns focus on communication between the objects, how they interact, and how responsibilities are distributed among them. They address complex control flow that can be difficult to follow at runtime. The purpose of these patterns is to increase flexibility in object communication, often by reducing coupling and increasing cohesion. Behavioral patterns can apply to both object interactions and class hierarchies, involving method invocations, object state changes, and algorithm selection. By using these patterns, developers can create more flexible systems that are easier to maintain and extend, with clearer separation of concerns. Let's take a closer look at some of the key behavioral design patterns and discuss how they can be applied. The patterns we'll cover include chain of responsibility. Allows a request to be passed along a chain of handlers, where each handler decides whether to process the request or pass it to the next handler. Command encapsulates a request as an object, allowing you to parameterize clients with different requests, queue or log requests, and support undoable operations. Interpreter defines a representation for a language's grammar and provides an interpreter to process and evaluate expressions written in that language. Iterator provides a way to access elements of a collection sequentially without exposing the collection's underlying representation. Mediator defines an object that coordinates interaction among a set of objects, promoting loose coupling by keeping objects from referring to each other explicitly. Memento captures an object's internal state, allowing it to be restored to that state later without violating encapsulation. Observer establishes a one-to-many dependency between objects, so when one object changes state, all its dependents are notified and updated automatically. State allows an object to alter its behavior when its internal state changes, appearing to change its class. Strategy defines a family of algorithms, encapsulates each one, and makes them interchangeable, allowing the algorithm to vary independently from clients that use it. Template method defines the skeleton of an algorithm, deferring some steps to subclasses, allowing them to alter specific steps without changing the algorithm structure. Visitor represents an operation to be performed on elements of an object structure, allowing you to define a new operation without changing the classes of the elements on which it operates. Each pattern has unique strengths and use cases, so understanding them will give you a valuable set of tools for your software development toolkit. Thank you. Let's continue in the next videos.